Okay, so on this question, we are subtracting a couple of fractions. And when you add or subtract fractions, you have to make the denominators the same. So let me write that. So when you're adding, subtracting fractions, you must get common denominators, right? You got to get the denominators the same. You can't add or subtract unless the bottoms are the same. Why is that? Well, it's just real life. Like, like say, I ate a half a candy bar and then later I ate a third of the candy bar. How much have I eaten altogether? Oh, it's a fifth. Well, no, you just know that's just wrong, huh? You can't eat a half. If you take if you picture like a whole candy bar here, and you said, yeah, I ate half, right? There's half. Then I ate a third, whatever I won't do, but they can't add up to be a fifth, right? That's just crazy. That's just not real life. So what do? Well, what that means is you got to make them both sixths, huh? You know what I mean? You multiply this one top and bottom by 3, this one top and bottom by 2, and it becomes 3/6 and 2/6, doesn't it? That's really, and then they add up to be 5/6, right? So in other words, you break this into sixths like that. And say, okay, so half, so there's a half, right? 3/6, that's half the candy bar. And there's a third, right? So this is a half, and this is a third. And they clearly add up to be 5/6. That's real life, isn't it? So when you add fractions, you have to make the bottoms the same, and then you can add them. So this is crazy right here. Then you can add them, and you keep the common denominator 6. You don't add the 6 and 6 to be 12, right? It's not 5/12 of the candy bar. So I'm just appealing to reality. That's all math is doing, is following what's true. So anyway, so you've got to get common denominators. Okay, so how do we do it? Well, notice what I had to do here. You have to multiply by the other denominator, right? I had the original denominators were 2 and 3, and I had to multiply the 3 here and there and the 2 there and there. So that's what you do. So let me bring mine over here. So I've got 3 over 2a, take away 3 over 7a. So what I'm going to have to do is I'm going to have to multiply top and bottom of this one by 7 and top and bottom of that one by 2. See how that'll make both denominators the same? 14a now. They both have the a, so you don't have to do any changing with that. But you got to multiply by the other number. Right? See how this has a 7, so I had to do the 7 top and bottom on the other fraction. And this one has a 2, so I had to do the 2 top and bottom on the other fraction to make them have the same stuff in the end. So now they're both going to be 14a and 14a, aren't they? I made the bottom 6. What's on the top? 3 times 7, 21. 3 times 2, 6. Now we can subtract them. What is 21 minus 6? I think 15. And the bottom just stays the same over 14a, and we're done. That's the answer right there. Put a box around it. So in the end, when you're adding, subtracting, so this is different than multiplying fractions. When we're multiplying fractions, we don't have to get the bottoms the same. Who cares? But when you're adding or subtracting fractions, you do have to make the bottoms the same. You can tell it's just the truth with the little candy bar example over here. So then you just multiply top. Now, why do we multiply top and bottom? Well, because we can't change the fraction, huh? Right? When you do the top and the bottom, you keep the fraction the same as it was. And so you have to multiply top and bottom. And then you can add or subtract, keeping the common denominator. And so there we go.